Now we'll look at patterns and algebra in this section. This video covers patterns and algebra, which is the second main topic under the Maths syllabus for grade 7. Under patterns and algebra, we'll be looking at number patterns, number sets, linear equations, and how to apply algebraic techniques to solve linear equations. You will be asked to solve questions involving number patterns where you will be provided with a series of numbers and a few missing numbers where you will have to fill in the missing number. Number patterns usually occur in two types. They are either in ascending order from small to larger numbers or in descending order from larger to small numbers. Let's take a look at a few examples and some typical number patterns that you will come across in your questions. Let's look at some number patterns under ascending order where you can see that the numbers are increasing with every subsequent number. So a common trend that you'll be able to observe is that the numbers will increase by addition. Let's look at this first example where the number increases from 1 to 3 to 5 and you're expected to fill in the fourth number. What's a common trend that you can see here? You can see that the difference between 1 and 3 is 2, and yet again the difference between 3 and 5 is also 2. So you can observe the number increasing from 1 to 3 and then from 3 to 5 increasing by a constant of 2. So what do you think the fourth number will be? If 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 will then be 7. So the answer here is 7. You may get similar questions where the number increases by incremental amounts, where from the first number to the second number, if it increases by 2, from the second number to the third number, it will increase by 3. And from the third number to the fourth number, it will increase by a value of 4. We'll be solving many of these questions and similar questions under our question sets, also displayed on our website. Another common trend that you can observe involving addition is the addition of the actual numbers in the number series provided. So for example, in this particular example, you can see that the number increases from 2 to 4 to then 6 and then 10 and 16. If you observe carefully, you can see that the addition of the first two numbers gives you the third number. So 4 plus 2 gives you 6, and 6 plus 4 gives you 10, and 10 plus 6 gives you 16. So what will be the next number? The next number will be 16 plus 10, which is 26. So this is another example of a pattern you can observe where the number increases by addition. You can also observe number patterns where the numbers increase by multiplication. For example, here you can see that the first two digits are multiplied to give you the third digit. So 2 times 3 is 6, 6 times 3 is 18. So what will be the blank number? Can you fill in that number? What's the response? The response is 18 times 6. 18 times 6 equals 108. Let's look at the other example, which involves multiplication. You can see that the number increases from 4 to 8, then you've got a number you've got to fill in, and then you've got 32, and then the number increases to 64. You'll be able to observe that 4 to 8 is 4 times by 2 gives you 8. 32 times 2 gives you 64. So we can see a trend of the number being multiplied by 2. Let's check if we've got the right answer. 8 times 2 is 16, which will be the answer. To check if it's right, 16 times 2 should be equal to 32, and it is. So we know we've got the right answer. You might also see number patterns involving prime numbers and composite numbers. A quick reminder, a prime number is a number that can only be divided by itself and by 1. A composite number is any number that's not a prime number. So if you see a sequence that goes 2, 3, 5, 7, there's a blank we need to fill in, and 13, we know that we are looking for a prime number. And what's the missing prime number here? It's 11. 11 is the only number between 7 and 13 that can only be divided by itself and 1. All the even numbers are ruled out because we know that 2 is the only even prime number, which rules out 8, 10 and 12. 9 can be divided by 3, leaving 11 as our only remaining prime number. Here's a sequence involving composite numbers. So we've got 4, 6, 8, and what are the other composite numbers between 8 and 10? We know that 9 is a composite number because it can be divided by 3, so you fill in 9 as your missing number. Let's look at more examples involving number patterns, here involving numbers that are in descending order, decreasing from larger numbers to smaller numbers. In this first example, you can see that the numbers are decreasing from 25 to 20 to 15. You can see that the numbers are decreasing by 5. So 25 to 20 to 15, and followed by, what will be the missing number? You take away 5 to give you an answer of 10. There's another example involving decreasing by subtraction. And your number is decreasing from 14 to 10, 10 to 7, and 7 to 5. What's the difference between 14 and 10? 14 minus 10 gives you 4. 10 take away 7 from 10 gives you 3. 7 take away 5 gives you 2. So your difference is decreasing. You go from 4, 3, 2. So what will be the missing number? 5 take away 1 to give you 4. Let's also look at some examples involving decreasing numbers, which involves division. So your number here decreases from 32 to 16, 16 to 8. You can see what's the difference between 32 and 16. 32 divided by 2 gives you 16, 16 divided by 2 gives you 8, 8 divided by 2 gives you 4. Yet another number where you can see that the number is decreasing by division. 81 decreases to 27, and there's a missing number which then decreases to 3. Here the number is decreasing by division, and 81 is divided by 3 to give you 27. 27 is divided by 3, and that gives you 9, which is your missing number. And to check if that's correct, 9 divided by 3 is also 3. So you know that 9 is the correct answer. There are two additional examples looking at prime numbers in descending order. You can also get questions involving prime numbers in ascending order as well as prime numbers in descending order. These type of questions test two areas of your syllabus. They test your knowledge of number patterns, and they also test your knowledge of whether you know what a prime number is versus a composite number. So in this example, your prime numbers 13, 11, 7 and 5 need to be followed by 3, the next prime number. Let's remind ourselves again, what is a prime number? A prime number is a number that can only be divided by itself and the number 1. Here we've got a decreasing list of composite numbers. You start with 12, 10, 9, 8, and what's the next composite number on that list? Can it be 7? No, 7 is a prime number because it can only be divided by itself and by 1. What's the next possibility? 6. Is 6 a composite number? Yes, because we know that all even numbers except for 2, which is a prime number, are composite numbers. So all even numbers are composite numbers. The only exception is 2. So we know that 6 is the next composite number. And the response to this question is 6.